This is for Year 12 methods. It comes out of Chapter 6, it's Exam Focus 36. Tasmania Jones is attempting to recover the lost Zanjibi diamond. The diamond is buried at a point 4 kilometres into Death Gorge, which is infested with savage insects. In order to recover the diamond, Tasmania will need to run into the gorge, dig up the diamond and return the same way that it came. The concentration of insects in the gorge is a continuous function of time. The concentration C of insects per square metre is given by that rule. Okay, so it's M for the first 8 hours. Then it's this squared cosine from 8 to 16, and then it's back to M from 16 to 24. What is the value of M? Well, it's a continuous function. Therefore, it's going to be M, something to do with the cosine, then M again. So, if I was to substitute 8 into the rule, and 16 into the rule, I should get this value here and here, which would be the same as M. So, I'm going to enter that into the calculator over here. I've got 1000. Then I have a cosine which is squared. So I'm going to open up a bracket in 2D, and on the outside of that bracket I'm going to square it. Then inside the bracket I'm going to have the cosine, so math cos, and I'm going to have a bracket inside of there, so I'll close that bracket for the bracket of the cos, and in there I have a fraction. And on top of the fraction I have pi, and I'm going to open up another bracket, x instead of t minus 8, all over 2. And inside this squared I've also got plus 2, and outside here I've got minus 1000. Okay, now what I'd like to do is I would like to option given x equals 8. It gives me an answer of 8000, very nice. And x equals 16. I should also get 8000, very nice. So m equals 8000. Okay, part B, sketch the graph. So I know that it's 8000 for the first 8, and from 16 through to 24 it's also 8000, and I'm going to label my endpoint. Okay, so what's going on in the middle here? What's going on in the middle there? I'll open up a graph and I'll sketch it and see what it looks like. Open up the graph, edit, clear all, okay. I'm going to change my window from 8 to 16. Okay, I'm going to get my rule, which is this. Drag and drop it. Zoom auto. And there it is. If I go analysis, trace, when it's equal to 8, when it's equal to 8, I should get an answer of 8000, very nice. Analysis, gsolve, trace. When it's equal to, that's 8 and that's 6, so that should be 12. Enter, I get an answer of 8000, so what will 10 be? 0. Okay, so I know that at 12,000, at 12 we're back up to 8,000, at 10 we're down to 0, and 14 we're down to 0, which should occur that looks like hard with the tablet to draw a nice curve, but that's at 14, that's at 10, that's back up at 8. What is the minimum concentration? It's 0 insects per square metre, that's the minimum, and that will be at 10 AM and 2 PM. Okay, part D. The insects infecting the gorge are known to be deadly if their concentration is more than 1,250 insects per square kilometre. At what time after midnight does the concentration of insects first stop being deadly? So we're looking at around about the value there and there, because that's going to be 1,250. So I'd like to know the X value when it's 1,250. So on my calculator, analysis gsolve xcalc for 1250, okay, and that gives me 9.33333, which is 9 1/3, and 1/3 of 60 is 20 minutes. So at the first time after midnight is 9:20 midnight, so AM. During a 24-hour period, what is the total length of time for which the concentration of insects is less? So the total amount of time is the difference between those two times and also the difference between those two times, which will be identically the same. So if I'm looking for the next time, it's 10.6666, which is 10 2/3, which is 1040. So 1040 is when it stops being not deadly. Therefore, that's an hour and 20 minutes. 2 lots of an hour and 20 minutes is 2 hours and 40 minutes in total. Okay. Due to the uneven surface of the gorge, the time taken is set up by this rule. And I know that it takes a time of 5 minutes. So t equals 5 when x equals 1, and t equals 12.5 when x equals 2. I have a rule, I can solve that simultaneously. So over here, I'll bring up my keyboard, I'll go variables. I want p bracket q to the power of x minus 1, close bracket, execute to make sure my variables are okay, take that, drag and drop. Now, I know that when x equals 1, that expression equals 5, which gives me equation number 1. And I know that that equals 12.5 when x equals 2. And that gives me equation number 2. I can then open up simultaneous equations, drag, drop, solve for P and Q. And that gives me 2 answers for P and 2 answers for Q. And then the question then asks how long will it take to run 4 kilometers? So how long will it take to run 4 kilometers? If I have my rule, which is up here somewhere, there it is there, and I copy that, and I paste that, and I have a few options. I know that P equals 10, and I also know that Q equals 1.5, and I want to say that X equals 4, and that gives me a time of 40.625. So multiply that by 60, and that gives me 40 minutes and 37.5 seconds. Okay, in part G, Tasmania takes 19 minutes to dig up the diamond, so that's 19 minutes. It takes him 40.625 to run in, and to run out it's going to be half that time, 40.625 divided by 2. So that gives him an answer of 79. There's my pen gone. Takes him 79.9375 minutes to run in the 4 kilometres, dig for 19 minutes, run out the 4 kilometres. So it's going to take him 79.9375 minutes. I know he's got to run 4 kilometres because in the first part of the question, the diamonds are buried at a point 4 kilometres. And we're asked here to work out how long it would take to run 4 kilometres. So there's my 4 kilometres. He's going to run twice as fast coming out. Now, will he successfully do this? He's going to have to wait until now before he leaves. Because if he leaves before 9:20, he's going to be eaten by the savage insects. So he has to leave at 9:20 and he must be back out at 10:40. 2 hours and 40 minutes duration, which is 1 hour and 20 minutes in duration. So he's got 1 hour and 20 minutes to get in and get out. He's got 80 minutes to get in and get out. It's going to take 79.93. Therefore, yes, he can successfully do it. And what will he have left? He'll have no minutes, and he'll have 0.0625 minutes left as a successful amount. So 80 minus this gives this, and that times 60 will give how many seconds he'll have spare. He's going to have 3.75 seconds spare.